All right. Thank you for joining me today. We have Don and Mike with us today. We're going to be doing a presence-absence online session. It's Friday at 2 o'clock here, and we're going to go ahead and get started with this. Hopefully you can see the presentations on the online session through Microsoft Live Office Meeting. And let's go ahead and get started then. What we have here is the EasyBuilder PowerPoint slides, which we present in class, and they are also here on our online session. So what we're going to do is determine some of the different types of presence-absence tools, describe some of those uses, and we're going to look at some graphs and jump over to the spreadsheet and look at some dependencies, how they are related to each other, and look at a simple brightness tool and implement it in a lab. We're looking at here a couple bottles, or a bottle here with some fluid in it, the bottle without the fluid. There's several ways to inspect this. One of the ways that we're going to use is a presence-absence, so we're just verifying whether there is liquid in the container. The liquid is a dark material, so brightness would be a good presence-absence tool to choose for this. Same thing with this application here. We could use some other tools. A presence-absence tool would lend itself very well here to determine if this product has a cap on it. Obviously, the part with the cap on it would be a good product. We also can determine whether that wick in the center of the cap is present also with another tool. Some of the tools that we have to offer here are presence-absence for under our inspect part, presence-absence, measurement tools, counting tools, and identification tools. Our presence-absence tools are merely there to verify an expected feature generally as a rule. Of course, our measurement tools are used for gauging and geometry. Within our presence-absence tool, when you expand that tool, we'll have several groups of tools. One's called brightness, contrast, max pattern, a pattern tool, pixel count, blob, edge, and circle. The brightness tool will average between light and dark pixels and give you an overall count or number between those two. Contrast is looking at the differences between that light and dark pixels. So if we have an edge between a light and a black background, the contrast value would be very high. The Pad Max is looking for a pattern. It will be recognizing that, along with our pattern tool, which is similar to the Pad Max, looking for groups of lines or even areas of light and dark pixels within the pattern tool. The pixel count tool is just looking for the total number of bright or dark pixels, not and, but or dark pixels within a search box. Blob tool is also looking for dark or light pixels, but the difference between the pixel count and the blob tool is the pixel count is looking for any dark or light pixels in a search area, the total number of those, bright or dark. The blob tool, the dark or bright pixels, must be touching each other. They must be contiguous to each other, touching on all four sides and possibly the corners. So that is the difference between the bright and dark pixels, between the pixel count and blob tool. Then we have the edge tool, which is just detecting the transitions between edges, light and dark pixels. If we have that, then we do have a edge presence. And the same with the circle, detecting change between light and dark pixels to determine an edge. The brightness tool, once you open up EasyBuilder, you can of course read the instructions here with the descriptions right over here to the right. As you have selected the brightness tool, you would add it, and this will tell you how to implement that tool. And that is with every tool that is given to you. Once you have drawn the box, the search box, or whatever tool it is asking you to draw, it will open up then a tab instruction box with the general, range limits, and sometimes settings tabs. So there'll be up to 3 tabs here. This one happened to open up with just 2 tabs with range and with general and range limits. First box here is used to describe the brightness or the name of the tool, and then it is also fixtured automatically for us. Whether the tool is on or not and its execution time. Range limits are going to be automatically done for us through the EasyBuilder user interface. They will determine what your brightness is by the actual tool itself, and then give you a range, minimum and maximum, which is automatically done for you. These are all default settings for you, which are done. The brightness tool will be using a graph to determine its values. Here is the threshold value, and then it has its range right here given. If you'll notice very closely here, we have a group of light pixels and darker pixels here, and determined by this threshold. If they're on this side of it, we do have dark pixels, or on this side of the threshold, they are considered light pixels. And we do have that representation then in this graph right here. To set up the tools, sometimes we do need to have some fixturing to be able to position our tools exactly where we want them to have. This one is using two edge tools to determine their position right here. Okay. So to add the brightness tool, click on brightness and add, and that will bring us to the search box here. To be able to enable that tool, we will have to draw it where we want it to look, and we drew it over this area right here to determine its brightness value. Once that's done, then we can see it graphs again. We have these three lines, the middle one being the threshold, in other words, determining light and dark pixels. To the right is light pixels, to the left are dark pixels, and these will be the range for that tool, which is determined through the range limits right here. Defaults to 129 and gives us a range. So if we have a group of pixels in here, and this is a presence absence tool using brightness, it will determine, yes, there is, it meets its limits and it is present. So in the results, we'll get some value in here, some number, and it will give us a status green or red, meaning, yes, this brightness is what I was expecting to see here, and it is present. If it is not present, this number will go up. We have a lot brighter background with this background, and the state changed to red, meaning it is not present. Because of its range limit, it is above its range limit, and so it is saying it is not present. Okay. Let's take a look at this. What I'm going to do is go ahead and jump over here to the actual lab, and let's take a look at what to do with this. I'm going to open up Insight Explorer 4.1. Taking a little bit of time to open up here. I'm going to go ahead and move this over so that you can see what's going on here for a quick second. Okay, this to here. Let me share this application with you as it's opening. All right. Now that we've got this sharing, what I'm going to do is connect to the camera here so that we can see what's going on. It's got a vision view panel. I'm using it right now, so I'm going to go ahead and take it back from that. And there is my camera, and the object I'm looking at is called the camera demo plate, which we've been using in classes featuring EasyBuilder. So I am connected to the camera. I'm going to go ahead and use a locator part, which we learned in another previous session, online session here a couple weeks ago, how to implement this. I'll just go ahead and draw this, say OK. let it generate that tool for me. I will recall it as fixture. And I will not adjust any of the settings. I will just leave it as fixture. Next, I will open up the inspect part, which is still all part of the second step. Inspect parts. Open up presence absence tools. And these are the groups of tools that I went through and described for you. I will open up a brightness test, because what I'm going to do is test for fasteners on here. There is a lab written out for you on this on the website, if you care to visit our website and download that. And it's a step-by-step procedure for examining for this fastener. As you can see here, I'll rename this as fastener. Okay. So here we have a fastener. As you see up here, it is 189 is its value. As we look at the range limits, we see here at 189 is in the center, and 208 170 are the maximum minimum. And over here on the graph, you'll see it's graphed out for us. So we have a small pile. If you look very closely here, again, that's going to be the background colors for us. So as I trigger this, it failed because my lighting values have changed. So I'm going to go ahead and change my setup image here. Got a little bit darker for lighting here. Okay, so let's see what we have for this. Okay, 167, 168 has changed the values here, so I'm going to have to go back here and go ahead and change this lower value to 150. And the 160, we can leave the upper value at 200. How we can test for this is I'm going to go ahead and flip this board here to the fail side. And as we see, the brightness went up to 208.579, which is not too much higher, so I'll probably lower this one down to at least 190 to give me a good 40 count here for my range limit. So now that I've dialed in that product right there for the fastener, and it is positioning with it as we rotate it here, we can tell it is moving with the demo plate. Now go ahead and put it back to the pass function. Again, that's 147, so we've got to lower this value. Okay. So that is our range. We had to adjust it a little bit there due to the light is changing here in my office. I'm not using external lights with this. And so we have the presence absence tool, how to use it, how to implement just merely the brightness tool. We have other groups of tools, but let me go ahead and show you another tool here briefly. Let me jump back to the slides. There. Okay, we were working with their concepts here. Let's take a look at what some of those are. The actual histogram graph, which I described briefly to you sooner, a little bit more graphical here in the sense of, as you can see, I have this group of pixels here and group of pixels here. I will call them light and dark because I do have a threshold here in the middle. And these areas right here are represented by this. And this dark area right here is represented by the background, which is apparent. Because as you see with this graph, looking at this search area, we just have dark pixels. There are no or very few bright pixels in this search area that we're looking at. And so that is how the histogram graph distributes the pixels here between 0 value and 255. which is not anything light or dark. We have to use the threshold to determine what a light or dark pixels are, and that's what we're doing with the threshold value right here. Another type graph that is used with presence-absence is a gradient graph to determine edges. When we do this tool, it is orientated by direction. It is a searching function within this direction, but notice as it searches this way, we just get a straight line on the graph, meaning I have not made a transition. Because right now when we're scanning across this way, we go from a 255 value pixel to probably a 0 or 40 value pixel, which means I have lighter and darker pixels, and by thresholding it, I can determine that there's a transition between a light and dark pixels, determining there is an edge. So that is the difference between the histogram graph and the gradient graph. The histogram is looking for the light, all the pixels. This one is just saying by score value, we have some 0 value going all the way up to 100%. In other words, we have a very good transition here. A gradient value between here and here is a very high value. A gradient value between here and this one, between 255 and 255, is not a very high number, so the score will be very low. We will not have a good transition there, if not at all. So that is the difference between a histogram and a gradient graph. The dependencies, when we drew the tool, I labeled this one as fixturing tool, and we put in the brightness tool. We called it fastener. It had automatically chained it to that fixturing tool so that when the demo plate moved, when I flipped it over to the failed side, it had tracked with it and put the brightness tool exactly where we needed it to be. So as I went through the lab with you during the PowerPoints, this is the lab. Again, it is written out for you. There is a lab document on the website if you care to download that lab for that. We also have some other labs that are associated with that. In the website, there are some lab images to be used with this. I'll show you one of these briefly and show you how to get to those. Again, this is another one just looking for the brightness of the holes in there. It is lacking a hole right there, so the score went changed and it failed. Same thing with the electrical bracket here. We have a brightness tool on here checking for that screws are there. As we change right here, the values will change and it will fail. So let's go ahead and jump out of this one and take a look at that Insight Explorer again. Go ahead and share that once again with you. Okay, let's take a look at some of those images. I'm going to go ahead to New here. And then I'm going to use this folder up here to browse for some images. This is what will open the playback record. We're not recording any images. We just want to be able to play them back. And right now I'm on our U drive here at Cognex, and I'm down to the electrical bracket. But as we open it up, you can see we have air freshener. That was that one with the cap that we had done the example in the PowerPoints. There's some bracket images. That's the one with the just merely a hole in there. The electrical bracket right here, which I've got it pointing at right now. So let's go take a look at how to use that one. And let's play that image right there. And there we go. We've got an image here. What we've got to do here is test to see if these screws are on here. So let's just take a look at how to locate the part. We use some pattern tools or a couple of edge tools would work also. So I'm going to add an edge tool on the, since I'm checking for this one, I'll add it right here. Okay, make it a little shorter here. So, and we'll leave that, and we'll create another edge tool. And I'll use this one as my second edge. There. And so now we have some locator tools, and I'll go to the inspect part. And let's go ahead and use in presence absence. I just want to see if it's there. So I'm going to use the brightness tool once again and just merely draw it over this screw head here. Say OK. And here we have fastener again. So let's take a look at how this tool is working. Range limits, it's drawing it right here. As you can see, the graph of pixels, dark and light pixels, it's averaged them out. So I'll go ahead and advance this another image here. And it is still passing. The screw is still there. Advance it again. It has failed. The tool, or the screw, the fastener has moved. And as you see, as it is there, it turns green again. So that is implementing that tool with just some edge tools now instead of a Max or pattern tool to locate it. I used two because I allowed for X translation and Y translation to move to that fastener tool itself. So there's another example using a brightness tool and presence absence, just looking at the brightness values. Okay. If you have any questions at this point, we can go ahead and join in the chat here, or I'll just go ahead and ask Mike first. Any questions? No. I don't see any from Mike there, and let's see about Don here. Okay, and none from Don. Well, gentlemen, since there are no questions for the presence-absence tools, we will conclude the session here with just reminding you that on our website we have the PowerPoint presentation that you just saw right here. Also, I am recording this video so that this live session here will be on the website also. And of course, the labs will be on the website under our training section under the Insight downloads. So I thank you for joining me today, and I hope you have a great day. Thank you very much.